Hi everyone, welcome to another Stellar session. The Stellar Bootcamp is powered by Hadao and Stellar East Africa. So we are teaching you about Stellar, and at the end of this program, all of you will be able to contribute to the Stellar open source and join their community. Our tutor for today is Ayomide. Take it away. Thank you.
Yeah. So, as usual, welcome everyone to our lecture for today. We'll basically be picking up from yesterday's class where we stopped, basically, and looking to complete everything concerning the introduction to Soroban smart contract. And that would then lead us to actually implementing Soroban smart contracts, basically. So I would like, if there's anyone that would like to give us a refresher of what we enjoyed from yesterday's class. And for those that have questions, if there are any questions you have from yesterday's class, yeah, Stephanie, basically. Yeah.
So good afternoon, everyone. From
Good
yesterday's
afternoon.
class, we started at the types of environment we have. We have the host environment and guest environment. The host environment is where we have the storage and vector. While the guest environment is the environment that spins off a virtual machine anytime we are communicating to one contract. Then we also the Wazin bicycle are found in the target folder. Then you spoke about the rules of Wazin, so that they are cross-platform portability, portable. They are they allow low latency contract calls and minimal gas fee. Then you also spoke about the host of events that provides reusable efficient data structures like vectors, map, and binary tree. You also spoke about host functions that offer essential utilities as just as a cryptographic operation like signing in and verifying message. Then you spoke about Sullivan contract written in constraint subset of Rust and the restriction that we have to follow so that there's no floating point at arithmetic. That means we cannot use any floating point so that we can know where the value stops. Like if we are only allowed to use fixed value, then we don't also allow multi-trending here. I think that is false. Then you said it will start as serialization to be.
Excellent. That's really impressive, You really did broke down every single thing we spoke about from yesterday's class. And I really do appreciate that. I really do appreciate that attentiveness to detail. So now we've gotten an overview of everything we discussed from yesterday's class. Is there a part anyone from this class does not understand or would like us to go back to? Because this class would basically be the last class on introduction. The next class we would be jumping in to writing the Soroban smart contract code from the next class. As this class would also include us installing the Stellar CIL, and for those that missed the Rust class, that means they would have to reinstall, the Rust program. That's the Rust C on the computers. So that would also be spoken about in today's class. But apart from that, if you have any questions based on the previous class or anything, now is the time to use the raise hand button to ask your question before we proceed. So there is no missing gap when it comes to your knowledge on Soroban. So are there any questions? Okay. So I will take that silence as there are no questions. So I'll start today by sharing my screen and literally proceeding from where we stopped the last time. So I'll share my screen. Yeah. So today we'll be starting from serialization and value encoding. Now, when you talk about serialization and value encoding, it's all about talking about the conversion of data. Now, serializing data, you're talking about probably you have a data structure or in probably in struct, and then you're trying to serialize everything to be in string, or you're trying to deserialize it. Now, as you advance in your Rust programming, you would learn to understand more details about serialization. But in this context, which we are talking about, it's just a method for us to convert our data in Rust structures, that's in structs, and convert it to, a storage format that aligns with the data we are storing on the blockchain. And as for Soroban, Soroban basically use the 64-bit integers as the universal format for their encoding values, whether it's a Boolean, whether it's an integer, or even if it's a reference to host objects. And if I can remember what host objects are from the previous class, we can see host objects as vectors, mappings, even binary trees. All of these are literally host objects, as we know. So whether we are trying to convert these data types into a form that is acceptable on the Soroban, on the Stellar ledger, all of this is what serialization is all about. And so by encoding this value in a compact format, Soroban reduces gas fees and increases the efficiency of contract execution. And it makes sense literally. Let me quickly show us or remind us this code we were working with. And let me do something. Yeah. So for this code, I'm going to create a struct, and I'm going to create that struct user. I just want to use this as a simple example, since this is just pure Rust. This has nothing to do with Soroban, but I'm just trying to give an example of what we are talking about here. And I'm not going to use serialization. I'm only going to show us a two different format and just ask a question. What's this two? I'm going to, comment out all of this. This is literally the guessing game with it. I'm going to comment it out. I'm going to create a new function, main here, and I'm going to do this basically. So I'm going to create this user. I'll name it user, and for it, I'm going to basically have it created. I'll name it John Doe, age 30. Now, there are two ways. I could print this user like this. I could print it like this and say user is, and I'll just do this. And then I would print the user. Now, if I come to my terminal, let me clear this. We have nothing. Okay, why do we have a problem? Oh, we didn't implement the bug. So we know we need to implement the debug traits here. That's the derived debug. Yeah. So I'm going to print it out. And I'm going to cargo run it. And we are going to see something. Now, can we see this? We notice that this is actually on a strict line. Now, I did not serialize this, or I did not deserialize it. All I'm just going to add to this is I'm just going to add something that will make it prettier. And then that's adding this. Now, if I add this, now notice the way the first one and the second one looks like. This is the first one here, user, on a straight line. And this is the second one. Both of them are the same data structure. But then the way they are printed out here is a kind of little difference. This is printed out on a straight line that makes it look like it's just a bunch of strings. And this is printed out in a format that is quite different. I mean, it's taking more space. You can think of the serialization as serialization in that format, a way to encode a structure or a structure for an object, for a data, encode it in a way that is compact and that is easier to store. And that's what we are talking about here, that Soroban literally allows for it, and it uses 64-bit integer as universal format for all of this encoding. So we were giving an example here. We said a contract calculating rewards for liquidity providers will serialize the reward data into a format that can be stored and later retrieved when users claim their reward. So now the data structure that is used here is more like a struct of the reward. So the reward data could include the balance, the amount staked, how long the user has staked it, and all of that, when he can withdraw. All of these could be part of it. And so it will be encoded and serialized in a format, and then when it is being retrieved, because obviously when you send your data to the blockchain, you obviously want to see what is there. So you have to do an interaction to, read from the blockchain. And at that particular point, the serialized form is what you see. Contract life cycles in Soroban. So there are basically 4 major life cycles in Soroban. Now, you can break it into whatever you want to, but this is just like how I like to see it. How I like to encompass the full cycle of smart contracts in Soroban. The first one is development. Development is a situation whereby you just begin writing the code, and you are writing the code in Rust, which is Soroban, it's a framework in Rust, and then you compile it down to Wasm bytecode, and then after compiling it down, you write your test. You basically, write test cases to simulate what it would look like, what the interaction or the behavior when interacting with your smart contracts, what the behavior would look like, basically. You could do that. That is the first part. All of that is done in the development cycle. So at that particular point is the beginning of your smart contract. And yeah, this for some, they believe this is the most important part of the whole cycle. But no, it's not the only important. As much as it's important, it's not the only important part. The next part is the deployment phase, whereby after writing your smart contract that you have tested it well, you've compiled it. Now that compilation, the wasn't bytecode gotten is what is then uploaded to the Stellar network. Now we keep talking about smart contract, we keep talking about the wasn't bytecode. Now notice that I've been hammering on all of these things. It's because I want you to remember it. I want you to remember when I start making use of this in the code. So it doesn't just become strange. How come it's not the code itself we are pushing to the blockchain? How come we are just pushing a file from that we cannot even read or understand? How come that's what we are deploying? How come what we wrote in our Rust language after the stress, we are not touching it? All of this is why I'm explaining this. So during the deployment phase, the only thing we'll be deploying from our smart contract is the compiled wasm bytecode. And this will just look like you are uploading a file. And so when you upload it, that is, you deploy it to the chain, it's basically going to be stored in the contract data ledger entry. And once it is stored there, a unique identifier will be given to you, more like an ID. It's a hash of that particular wasn't bytecodes. The next part is execution. The execution has to do with interaction with your smart contracts. After you have deployed your smart contract, you definitely need to interact with your smart contract. So that means that this particular part is where you start, making a write call, a read call to your smart contract. And so all of this contract invocation, what happens at that particular point? It's when your smart contract is basically being used. For me, I feel this more like the important part of everything. I'm not saying any part is not important, but after you've written your code, the most beautiful thing about your code is when it's being used. So yeah, the interaction. And at this particular point, a virtual machine is always pinned up to ensure that your smart contract is running in an isolated environment, to ensure that it is not it is not interacting or intercepting with another smart contract that it is not meant to interact with, or it is not opened to attacks that might come up, and that's why a virtual machine is being spinned up. It also gives access to, host functions that we've made mention of. And these host functions literally gives room for reading, writing from the ledger, basically. Then the execution is what we've just made mention of. The next one is the termination. So when a smart contract is no longer needed, it's literally terminated. And this is where what we were talking about when we were talking about different storages that you can apply for your smart contract storage. So in the termination phase, all the associated contract instances and the storage are basically cleaned up from the ledger. And this literally frees up resources, like I made mention of. When something is not needed, it doesn't need to be kept. You've used the smart contract and it has achieved its goal. Let's clean up the environment. Let's not keep redundant items. Let's make the chain faster and lighter. Imagine a situation whereby you can run a full node on your device. You know how interesting that would be. So this is giving room for opportunities like that. And so at this particular time, you can no longer interact with that smart contract. And the contract storage, the contract instance, everything is cleaned up from the ledger. And so you can no longer then have access to it. Now, one beautiful thing about smart contracts is upgradability. Now, if you talk about upgradability, you can think of upgradability for those coming from the Ethereum EVM background. You can think of different types of upgradability in the Ethereum area. And in that case, the upgradability is all about, you can literally think of anyone. Which ones are coming to my mind right now? You can think of UUPS, Universal Upgradable Standard. You can think of Transparent Upgradable Standard. You can think of minimal proxy. You can think of Beacon. You can think of EIP 2535. That's Diamond Standard. You can think of any kind of upgradable proxy contract that actually still applies to Stellar. But in this case, it's in fact a very good way, an easier way. Because first of all, we want to remember that every contract already, the implementation is not inside of that contract. The implementation is inside of that wasm bytecode that has been uploaded. So that means that each contract instance is connected to that wasm bytecode. But then, if we disconnect the wasm bytecode from that contract storage and we connect it to a new wasm bytecode where the implementation is, can we not call this upgrade? Well, the answer is yes, we can call it upgrade. So contracts can also undergo upgrade, allowing new wasm bytecode to replace the old version without actually interrupting the existing contract state. So remember that each of these contracts that has been initialized or instances that has been created from this wasm bytecode, they have separate storages. And so as long as you disconnect from the old wasm bytecode and connect to a new wasm bytecode with added implementations or changed functionalities, all of this will just, make the contract continue. And it makes it even simpler for upgrade when it comes to smart contract, especially smart contract that implement wasm bytecode as their major form of implementation. Moving on, what are the tools for contract development? Well, Stellar did offer some tools for development. I mean, there are some blockchains. I wouldn't want to name any blockchain, but there are some blockchain where you would hardly find documentations, you hardly find tools. And if you find tools, you hear that some of these tools, there are no support. You go to the Discord, there are no support, but it's not like that in this case. So there are developments that allows developers to basically build with the tools One is the Soroban SDK. It's literally a set of libraries and tools that helps developers to build, test, and deploy contracts in Rust. So the Stellar SDK is one you'll be working with very soon. Then the next one is the Soroban CLI. The Soroban CLI literally is a command line interface for interacting with your contracts, and it performs different things like compiling of your smart contract, deploying that smart contract, even invoking the smart contract, and inspecting the storage of your smart contract. All of this is done using the Soroban CLI. Now, when we say inspecting the storage of your smart contract, remember that we made mention from previous lectures that your smart contract storage could either be temporary, permanent, or an instant storage. Now, as a developer, you might want to inspect how long your smart contract has to live before it is completely archived. Now, you can do this basically by using the Soroban CLI. Now, while you are writing your code, now you can just keep this at the back of your mind, but when you are writing your code, some people might like to create functions in their smart contract where they can basically check how long their smart contract can live. But it's even easier to use the Soroban CLI to do this. Now, we have the Stellar Horizon API, we have the Soroban Localnet. So there's an IDE that allows for easier development. I did not add that IDE yet. It's not meant to be Soroban Studio. I did not add that IDE. So I'm going to add it later on. So there are other IDEs that look like Remix, but not Remix for Stella. The name is not coming to my mind right now that you can basically use for easy development. In fact, I'll probably start with that, but I rather want us to, understand how to spin up a new project and start immediately. So workflow, write your smart contract in Rust, compile. Okay, I think there is a comment from the Q&A. Oh, thank you. It's called the laboratory. Exactly, exactly. Thanks for reminding me. It's called the laboratory. It's called the laboratory. So it's just like Remix. Just like in Remix, you can quickly write your Solidity code, and using this Solidity code, you can compile it, you can basically test it. In fact, you can deploy your Solidity code when you connect it to your MetaMask wallet or any injected wallet you want to connect it to, and deploy your smart contract from Remix. So just like that environment, you also have it laboratory for what? For Stellar, where you can basically what? Interact with your contract. You can write your contract and test everything basically there. So you compile it using cargo build, test locally, and then you deploy it to using the Soroban CLI. Now, one important part we really, really, really need to talk about is the gas fees. Now, I really want someone from the audience to tell me, what do they think gas fees are? And well, that's not the major question. And the major question is, what do you think gas fees are, and why should gas fee be important when you think of blockchain? And what are consequences for situations where there are no gas fees? You can use the raise hand button if you have answers to these questions. That's before we talk about gas fees. I want to hear everyone's opinion. Yes, please. Matutu, please.
Hi,
Yeah.
hi. Gas fees are the transaction costs that are being used when the sender sends the blockchain to another sender. Is the amount that the user uses, but it's somehow less than the amount being used. It's like, example, in Kenya, there's the transaction fees when you send M-Pesa. So gas fees like that. I would say the answer to that's the first question answer. Answer to your third question, I would say gas fee is important because it makes the transaction to be quicker. than when there's no gas fee. Because when there's no gas fee, I think because it's not profitable, so someone will take time before the transaction is confirmed, unlike when there's gas fees.
You see, Matutu, this answer you answered. The first one is very correct. The second one is correct too, but it is controversial. You know why I said it is controversial? It's because, interestingly, validators on the Stellar network are not incentivized. So the gas fees are not going to them. So that's why I said it's controversial. So now, validators and miners on the Ethereum network, they are incentivized. They get these tips from these gas fees, right? But on Stellar, it is different. So having this knowledge now, would you still give that the same answer you've just given?
No.
Good. So do you have
I've
something else?
accepted.
Or I
I've
should.
accepted the correction. Yes, I'm
Okay.
satisfied.
Okay, great. I appreciate you so much for your answer. Thank you so much for the participation. Let me hear for intro, please.
Yeah, I think gas fees are there to prevent like indefinite computations. There needs to be a cost towards like maybe calling variables from the blockchain or performing any type of computation on it to prevent like while loops that never end and things like that.
Excellent answer. Thank you so much. Thank you so much. Now, we want to remember that I always say this. The blockchain is like a world computer. Everybody is participating in it. Now, imagine you create a computation that goes on forever. What then happens? Or imagine you are trying to create a loop for a DDoS attack. What then happens? So the gas fee is basically there to avoid all of this. So with introducing the gas fee to the blockchain, it helps eliminate computations that are not meant to be sent to the blockchain. And that is why when I started this lecture, I made mention that due to the fact that gas fees are introduced to it and not all computations can be, computed, we called the Soroban a quasi-Turing machine, basically, for the network. So that leads us back to the slide. But thank you so much, Intro and Matutu. Those are very great answers. I really appreciate you. So we said gas fees are a key consideration when you are designing your smart contract, as they impact both the developers and the end users. What do we mean by this? Now, when you are building your smart contract, it's always important that you put into mind optimization. Now, what do we mean by optimization? It means that you want to understand that you do not want to create excess memories that are not being used. So you want to optimize your storage. You do not want to create indefinite calling to storage when you can basically call to memory. Now, in Solidity, there are things like storage packing for you to, minimize the amount of storage that is being used for, your storage variables. Now, you can think of for those coming from the EVM background, you can think of different ways you can optimize your gas and then implement these also in Soroban. For example, there are situations whereby for variables in Solidity where you would need to use a U40, uint 40, because you know that what you want to the variable you are trying to build, it's probably a variable that has to do with time, and you know that it's not going to pass something like that uint 40, because that's basically 2 raised to power 40 minus 1, and you calculated that and you understand that, okay, it's not going to pass that, and then you use uint 40 instead of using uint 256. That is basically managing of memory, and this leads to what? Good gas efficiency. So a situation whereby you don't need to excessively use memory. That is, you understand how it's important. You are not always calling to storage. All of these literally minimize the gas use. So you can think of storage access, computation, and external calls. So there are situations whereby you need to interact with the ledger. And you understand that the contract size you are trying to interact with when it comes to the data you're interacting with the ledger. Okay, there is something. Okay, Maru, you've got a question. Yes, you can unmute and speak, please.
Yeah, you said that Stella earlier. You said that on Stella we're not incentivized. So why
Yeah,
would anyone want to be a validator on Stella?
good. It's for decentralization. It's for decentralization. We want to remember the original reason for the blockchain. The original reason for the blockchain is to create decentralization. And now imagine, because I'm not incentivized, I don't want to run the node, then how then would the blockchain be decentralized? One of the important things about decentralization is having different nodes that are running in different geographical locations. So for this reason, it's important that everyone engage in this. Okay, someone else. I would want to think of it that way. Yes, I would want to think of it that way. Yes, yes, I would want to think of it that way. I would want to think of it that way. But you could come to the stage and talk more about that. But are there more questions you have, Maru? Your answer is still up.
No more
Okay,
questions. No more questions.
Dennis, I have a question then.
I've not understood. I'm interested in that Maru's question.
Okay. What do you mean? You mean why you still feel a system whereby
I've
you are
not
not
gotten
being paid?
explanation
What?
because you said I've not gotten any explanation because in EVM we know that gas fees it's normally to incentivize the validators to validate
Exactly.
transactions.
Exactly.
But
Exactly.
I've not gotten the part of Stellar. How does it operate?
Good. So here is how it operates. Now, for the gas fees do not go to the validators. The validators are not incentivized. So the validators run the node because they want to keep the network decentralized. Now, so many people get involved in running a node just for the fees they would enjoy, the money that comes from it. In fact, some people use it as a business model. They create a rig and then they start running it, mining. Although since, Ethereum moves to proof of stake from proof of work, there's some people they put together up to 32 ETH, and they basically put more than that even on ground just for this. But if I'm to ask you a question, Dennis, the fact that now this is a controversial question, but I just want to hear your opinion. The fact that um, validators need to have, now I'm talking about Ethereum, not even Bitcoin that is still on the proof of work. I'm talking about proof of stake. The fact that people that have to, run a node need to have up to 32 ETH, and 32 ETH, if you are to check the price of ETH today, I don't know the exact price, but I think it's between $1,000 to $3,000. And so if you multiply that, that's kind of a huge amount of money. And so that means for you to participate as a validator, you need that huge amount of money. Can we say only those that have that huge amount of money and they are able to participate is truly making it a decentralized system, since people that do not have that amount of money cannot participate as a validator? What do you think?
So I think plutocracy is bad, and it's a major challenge even in the blockchain right now.
I didn't get that. I didn't get that.
I'm saying plutocracy, whereby the people with the, let's say, the highest amount of Ethereum gets to, validate.
Yes.
It's not good because I think that because it's blockchain, people deserve all opportunities.
Exactly.
And
So if
that's a
it's
challenge. That's basically a challenge that's not only faced by the Ethereum ecosystem, but more research is needed to solve that.
exactly. Exactly. So if you look at the comments, intro literally made mention of something. It says plutocracy, a situation whereby the society is ruled or controlled with people of great wealth and income. So you can think of it like that. 32 ETH is a very large amount of money, basically, if you are to convert it to dollars. And so are we saying because these people that have the amount of money to run a node, 32 ETH, they should be the only one that should be in charge of the decentralization? You see, that becomes a controversial statement when it comes to the blockchain. Now, that is why Stellar, I am not the creator of Stellar blockchain, but it makes sense to build a system that is open to everybody, as long as you have the resource on your computer and you can basically run the node, then you have access to even what? To even verifying transactions. Now, there's a beautiful thing about it, although because our curriculum is captured into about 1 month, I would have loved to talk about how the consensus mechanism of Stellar works. It's a very beautiful one. They make use of what we call the Federated Byzantine Agreement. And now this Federated Byzantine Agreement has different processes. First of all, to become a validator, after becoming a validator, you create a quorum. Now, after creating a quorum, that quorum includes validators on the Stellar network that you trust. Now, when you send a transaction for validation, out of that quorum, you need a threshold. Now, a threshold is needed to verify that transaction in your quorum. Now, if the threshold from your quorum is not reached, then a different quorum picks it up. Now, if a different quorum picks it up and then there's a blocking set, there's something called blocking set in the system. If the blocking set comes up and blocks the transaction, it is then not added. So there's a whole lot to what goes on when it comes to the Stellar consensus mechanism. And when you think about the validators, one of the major things is for the consensus mechanism, basically. So Intro adds something to say.
Yeah. Again, maybe it's a problem of coming from like the Ethereum ecosystem onto somewhere else. We're carrying the same conceptions and trying to port them here. But I'm trying to ask if there's the way Stellar Core works. Is it also separated into the consensus and execution layer? Because I'm struggling to find any information about that exactly, and how also transactions work on Stellar.
Oh, I guess you were not opportune. Were you opportune to join the first classes we had?
Yes.
Okay, okay. So due to the fact that the classes includes us talking about introduction to blockchain, introduction to Stellar ecosystem, introduction to Rust, now introduction to Soroban. Each of these topics are enormous topics on them in themselves, but I've tried to compress them in. But now there's a different class I also take, and some of my slides literally breaks all of these concepts down. Now, if you want to, you can privately message me on the Telegram, and I could literally send you my slides. And in fact, I can send you some playlist of classes I've taken on each of these topics that basically speaks about Stellar in a deeper concept, talking about how the transaction works. And yeah, I like how you were able to break it down when it comes to the Ethereum core. Now, for Ethereum core, we have different packs, the execution layer, you have the P2P, you have the consensus layer, different layers like that comes together to make the Ethereum core. Definitely, we also have something like this in Stellar. What makes up the Stellar core? We'll definitely have it. In fact, in one of those classes, I was able to draw an architecture that brings together everything that makes up the Stellar core. So yeah, I'm going to send that slide to you if you really want that, because this class would not contain us to, talk about all of this. Although I've just made mention of what the Stellar consensus mechanism is, that the Federated Byzantine Agreement for Stellar, even though that's not exactly part of this curriculum, just to talk about how how consensus is reached between validators that are not even incentivized. So yeah, you also have something else to say. I noticed you're muted.
No, I was just saying thanks.
Okay, great. So we've spoken so much on the gas fee, and I guess so many people aren't happy based on the fact that you are not going to run a node without having to get paid. To run a node, you need resources, your computing power, electricity, and all of that. So, run a node, and you would not want to run that without having something in your pocket. But would you want other people that have money in their pockets to run this, and then you are just left to agree based on the decision that is being made to the transaction that is added? So that's one for you to think about privately. So what are ways to reduce gas costs? You can use host objects like vectors and maps efficiently. You need to avoid unnecessary allocations of data duplication. There was a Soroban smart contract I audited few months ago, and in fact, this was one of the major things I pointed out in the report, using of allocations wrongly, data duplication. This is where you really don't need to keep calling to the storage. You keep calling to the storage when you can just, keep the data you've called to the storage once in a memory in your function, and then keep using that data unless you want to store back to the storage. That's literally one. Leverage on temporary storage for data that doesn't need to be persistent. Yes. For you really don't need to create, there are some methods you really don't need to create, whereby that's calling to the storage. Some, read functions that doesn't necessarily need to be stored, and then you start using operations that are not needed. You want to minimize this. Also, minimize cryptographic operations unless absolutely necessary. This is very, very important. A situation whereby you do not need to hash data together. There is no need to do this because this takes up computations, and more computations leads to more gas consumption. So as much as possible, minimize cryptographic operations. Are there more questions? Okay, someone said drop a note to the consensus mechanism for Stellar. Yes, I'm going to drop that. I'm going to drop that. At the end of that, of this class, I'm going to drop a slide that I created, a slide just like this one that I created for that. Then, moving on, Soroban and DeFi. Just like Ethereum, you can basically think of so many decentralized finance. Now, you notice that this list I've made mention of includes decentralized finance, but it's not, you should not only think of the financial aspect of a blockchain. Although one of the major focus of Stellar is to, bridge that cross boundary payment systems. That's why they created something like Anchor, the Stellar Anchor, where you can literally integrate into, decentralized finance with traditional finance. Yes, you can do that basically. But I personally, I don't want us to always think of just the financial aspect of of the blockchain. Think of other infrastructures that you can implement the blockchain with, and you know would lead to better adoptions. Although, as you can see from this slide, there are things like automated market makers. When you talk of automated market makers, literally comes from the idea of talking about Uniswap, the version 2 of Uniswap, and so many people picked it up and begin implementing something like this. Another one is lending protocols where users can borrow and lend assets with contracts basically managing it without having to keep an intermediary. The contract will be the one managing the collateral, the interest rate, and the payment. There are new protocols that are actually building this out right now, and you can go through it. We have yield farming where you can stake your tokens and get rewards at the end of the day. Synthetic assets where contracts are created and it's managed synthetic representation of real-world assets. Then stable coins. What are security considerations you should consider when dealing with the Soroban smart contract? First of all, we want to ensure that any contract handling large sum of money must go through audits, and it has to go through, it's basically have to have enough access controls, and even fail safes. So when you finish building your smart contract and you know that at the end of this day, this smart contract, it's used for any of the above, it really still needs to go through a whole lot of audits. Because, most of the time, the money in the smart contract is usually not your own, it's the user's own. And I'm not sure you would want to have cups in your hand due to mismanagement of funds based on the fact that your contract is act and you're unable to repay the users back. So it's important that you go through thorough audits before deploying any smart contract. Also, upgradable contract allows for continuous improvement without locking users into outdated systems. Yes, I think that's one of the most beautiful things I like about blockchains now, because when you start learning about smart contract, even for those coming from the EVM background, the first thing you will be told about smart contract it's more like smart contract are irreversible lines of code that when deployed, they cannot be reversed. But talking about, improvement proposals that have led to, upgradable smart contract, that literally boils it down. It's just like when you are probably in high school and they tell you, or you are in elementary school and they tell you, you cannot minus 1 by 2. You can't say 1 minus 3. It's not possible. And then you get to high school or college and you're told that 1 minus 2 is basically minus 1. You get fascinated and not like that. It's just the same thing like that when it comes to date. But yeah, you can think of the concept like that. So allows for upgradable contracts and all. Okay, I think there is a comment. Oh, yeah, something like you cannot do a square root of a negative number. And then when you get into high school or you get into college, you are told that, oh, it becomes, is it real? You categorize it into real number and unreal number or something like that. It becomes I. So yeah, something like that. So yeah, I like that. I like that. I like that. So moving on, cross-contract calls. Now, there are different types of smart contracts that are being built. And why I would always still refer to the EVM background is because most people are usually coming from the EVM background. Now, for EVM background, you understand that when you are interacting with a contract, you probably would understand that you need to use an interface to interact with that smart contract. It means that for you to call that smart contract, the function selectors is what you would call from the smart contract. I think there is a comment again. Okay. Okay, yes. This is great. I think instead of dropping it here, why don't you just drop it? Let me copy it and just drop it inside of the chat.
I just did that. We can continue.
Okay. Okay. Great. So smart contract interaction, that's cross-contract interaction, is all about interacting with another smart contract that has been deployed. So let's say, or even when you are writing your smart contract, you could write 2 smart contracts simultaneously, and you would want to interact with the other smart contract. It could be direct invocation, whereby one contract calls another functions from another contract, and it then takes the data, receives the data or the results that comes from that smart contract, and then it's being used in the other contract. So there is cross-contract calls. There's also data sharing, whereby contract can share state or read data from each other's storage. All of this, it's just based on how you want to implement your contracts. You can think of one popular example when you think of cross-contract call most times is when you are writing a contract that deals with oracles, and you want to get a price field. For example, for those coming from the EVM background, you use Chainlink for that basically. So you want to get a price field for certain tokens, and you want to get real life data simultaneously like that. You can use different price field, and to interact with this chain link, you need to do what we call cross contract. So the same thing is what is happening here. So you can literally interact, get the data state of the contract, or update it, another contract state, or even trigger a function to do something else. You can even have so many cross-contract calls that could serve like a chain of contract A calling contract B to call contract C. So you can go on and on and on like that. So what are some use cases? A lending contract can interact with a price oracle contract. I mean, I literally just said that. Another one is government contract can trigger other contracts to update parameters like interest rate or token supply. So all of this is possible. So it's possible for your contract to literally interact with another contract that has been deployed on the blockchain. Security in Soroban smart contracts. Security is a top priority when developing your Soroban contract due to high stakes of decentralized application. So what are some of the great things? We have isolation. Contracts run in a sandboxed environment, preventing malicious action from affecting other contracts or the ledger. And that's what I think throughout this slide, we've made mention of this probably 4 times. It's just for you to exercise your brain muscles, for you to remember these things. Sometimes you see some things that are, repeated over and over and over. It's more like repetition. It's more like the father of learning, something like that. Yeah, access control. We've also spoken about that. Replay protection. Soroban includes mechanism to prevent double spending and replay attacks on transactions. When you go for some blockchain interviews, one of the questions they would ask you is, what are some security vulnerabilities? Sometimes the first one that would definitely come to your mind is reentrancy, or then you can think of signature replay, you can think of double spending. But most times reentrancy attack, it's more like what you think of most times. So yeah, some of these things are the things, security considerations you think of when it comes to the security of your smart contract, your Soroban smart contracts. Another one is auditing and verification. Your Soroban, it's encouraged that you always go through audit. Now, earlier we were talking about audit when it comes to smart contracts that holds enough finance. It's also nice, even if your smart contract doesn't deal with finance directly, it's also nice and important that you have an audit report, especially when you are creating smart contracts that would be reusable by other developers. It's always important to have it audited. And that thing is panic handling. It's important that you undo your revert statement very well. Now, from our Rust class, I've explained some ways we can use result enum to, undo some panic. And I, in fact, showed the difference between a situation whereby a function is not handled well when it comes to error. I used the example of an example of uh, um, um, a division, a fraction, where you are dividing probably any number by 0. It literally gives you undefined. In such situation, imagine you have a smart contract where you are passing in some particular fraction and you're doing some arithmetics in your contract, and then you are dividing a number by 0. How do you handle that situation? Do you handle a situation whereby you are dividing by 0? How do you handle a situation whereby the decimals are lesser than what you are trying to divide it by for probably a token and all of that? It's important that you handle all of these securely so that your smart contract don't terminate upon execution. Upgradability and versioning, we've made mention of this, using proxy contracts to store contract logic, allowing for upgradability. We've spoken on this. And then for testing, we have unit test, integration test, force testing. Now, that's the beautiful thing about writing your smart contract in Rust. I mean, you have opportunity to even force test it. I know for people that are writing your Solidity, yes, you can use Foundry for this. You can basically force test using Foundry for this. But I mean, Foundry was built with Rust too. But then at the end of the day, when you are using the main language for the main contract itself, not that it's more like you are using a part of it for it, and you are writing the main contract in Solidity, and then you are using Rust, to compile and do all of this. For this case, you have direct access to the major tool. When the language itself, it's more like Rust, basically. So you have opportunities to basically force test and you do unit testing, integration testing. But let me ask a question. Can someone tell me the difference between integration tests and unit tests? Sometimes this is literally questions you get from a blockchain interview. So let me ask, can anyone tell me the difference between unit test and integration test? Anyone? How come there are no hands? Can everyone still hear me?
Yes.
Oh, everyone can hear me. It's just that there are no hands raised up. I haven't heard from Cynthia. Yeah, no, before I hear from you, intro, I haven't heard from Cynthia. Cynthia, let's hear from you. Please, can you bring Cynthia to the stage? Let's hear from Cynthia. What's the difference between unit test and integration test? Or are there any difference between these two? You cannot mute. Cynthia, we aren't hearing from Cynthia. Okay. What of okay, let's hear from Maru. Okay, Maru, yeah. Maru.
So the basic idea of unit testing is testing individual functionalities or components of a system, or let's say a smart contract. Whereas with integration testing, you test all the components together if they mesh up well and they do their required function. That's basically it.
Thank you very much. Thank you very much. That's very correct. Could you give me a scenario where you would need to do integration testing? Or are there scenarios where you do not need integration testing and you would just need unit testing?
So I think for unit testing can be needed only when it's like a very small system with very specific goal or task or functionality. But provided there are multiple moving parts of a system which can work or perform different functionalities, then an integration testing is crucial so that we can see how each component of a particular system functions.
Thank you so much, Maru. Thank you so much. Yes. So in essence, while you're writing your code, you always have to think of both unit test and integration test. For a situation whereby you need to test a particular contract. Now, let's use the example that I was given in the slide. Your contract is using a price field from an oracle. In this particular case, in the Solidity environment, you do what they call mainnet forking, and you can do it using Foundry or even adaptable to do this. And so in this particular case, you do that for what? For integration testing to ensure that, okay, what you are interacting with is actually what? actually giving you what you need during your testing. And so you perform an integration testing for that. So thank you so much, Maru, for the answers. So this is how we come to the end of the introduction to Soroban smart contracts. So the next thing we'll be doing in our next class, which is on Monday, is we will be installing the Stellar CLI. And for those that do not have Rust on your system already, we'll be installing Rust because you need that basically. So you will install both of them, and then we will start with building a smart contract. Now we have a list of smart contracts that we are targeting to build. And I hope we are able to cover all of these smart contracts in our class next week. So at this particular point, we would come to the end of our class, but are there any questions based on everything we have discussed from today's class or previous class? You know, it's good when we discuss these questions that it's easier to, you know, catch up when your questions are answered and not piled up. So are there any questions? Okay. Since there are no hands raised up, I would believe that everything from today's class has been gotten. And so thank you very much, everyone. I appreciate your attendance to this class. And for those that participated, I really do appreciate your participation. And it shows that we are all doing what on good track to become, you know, a Soroban smart contract developer. So thank you very much once more. I will be leaving the stage for IJ to take over. And yeah, bye everyone.
Hi, everybody. Thank you so much for listening. Thank you so much for attending. And I hope to see your tweets, see your engagement, see your questions, and see you guys next week. Cheers. Have a nice weekend, guys.